Okay, so for today's lesson, we're going to be looking at the key features of quadratics. And before we go into our examples, we got some things that we need to go over. First thing is the formulas. Formulas that we need to remember is like standard form. And standard form for us is going to be y equals ax squared plus bx plus c. That is a standard form quadratic. The other formula that we need to remember is the axis of symmetry. And axis of symmetry is where we have this x equals negative b over 2a. Okay? Now, with that, we have some definitions. The first definition that we got is domain. Domains for a parabola is always going to be all real numbers. So anytime they ask us to state or list the domains, we're always going to write all real numbers. Okay? And then the other one is range. Range is depending on the direction of the parabola. So if the parabola opens up, then our range is going to be y is going to be greater than or equal to our minimum value. If the parabola opens down, that means that it's going to be y is less than or equal to the maximum value. Okay. Now here's just a little sketch of what I mean by maximum and minimum. Minimum means that the lowest point is at the bottom and your a value is a positive. Maximum means that you have your a value or your highest point is at the top of the parabola and your a value is going to be a negative. Now with that, we also need to remember some definitions that we had prior. And those definitions are dealing with the points where the parabola crosses the x-axis, which is your x-intercepts. Now, x-intercepts have some other names that can be used, like zeros, roots, or solutions, okay? Now, those names can be used in any one of the problems, so you're expected to know that they're still talking about our x-intercepts in that. Now, the steps that we're going to be following in order for us to get our key features of a quadratic is the first one, is that we got to find the axis of symmetry. Then after we find the axis of symmetry, we need to find the vertex. Then we're going to find the y-intercept. That's a new part. And then we're going to state whether we have a maximum or minimum value. And then we're going to find the solutions. Now solutions, again, x-intercepts. So we're going to find the x-intercepts. And then we're going to state our domain and our range. Those are the key features that we have to list every time when we're looking at a quadratic. The reason why we need these key features, they help us graph the quadratic. So in this lesson, we're also going to be finding those features, but we're going to be graphing it as well. Okay. Now the bottom part of this is a full example of what we're going to be going through. And then if you notice on the actual parabola, you're going to see there are 1, 2, 3, 4, 5 dots. So every time that we graph a parabola, we need at least 5 dots. That will give us a good parabola to graph, okay? And all of those 5 dots, we got our x-intercepts, which is our solutions. We have our vertex, our y-intercept, and then the 5th dot, which is here, you notice that it's an equal distance from the y-intercept to the other side of the parabola, or it's an equal distance around the axis of symmetry. Okay, so those are the things that we're going to be doing to find the key features of a quadratic. Now let's look at our example. All right, so let's look at our first example. In this example, we need to graph the equation. So in order to do that, we need to identify the axis of symmetry, the vertex, the y-intercept, the direction, the roots, domain, and range. Now, in order to graph, we need to find all these key features first, and then we can put it on a graph. So let's get started by listing out what our A, B, and C will be. In this one, our A is 3, our B is 12, and our C is 9. Now, the direction in which it opens is based off the A value, whether it's positive or negative. And because this is a positive A value, we're going to have a direction that opens up. Okay, now we're going to find our axis of symmetry. The axis of symmetry is based off our formula, which is x equals negative b over 2a. Now the negative is already there. Our b value is 12, so we're going to put that beside the negative. We're going to divide that by 2 times our a value, which is 3. So that's going to give us negative 12 at the top. 2 times 3 is 6. So we got negative 12 divided by 6 will be negative 2. So our axis of symmetry is x equals negative 2. Now to get our vertex, we'll take what we got for axis of symmetry and plug it into the equation. So that means we're going to have 3 times negative 2 squared plus 12 times negative 2 plus 9. Now we can go to Desmos for that to help us out. So when we get to Desmos, we can type in 3 parentheses negative 2, raise that to the second power, plus 12 times negative 2 plus 9. And that's going to give us negative 3. Now, the point that we just found is the y value, and the axis of symmetry is the x value. So that makes an ordered pair for the vertex. So our ordered pair for our vertex would be negative 2 and negative 3. And we got to remember that came from our x, which is the axis of symmetry. And when you plug it back in, that gives you the y value, which is negative 3. Okay? So we got our vertex, our y-intercept. The y-intercept is in the actual equation already. It is the c value. So whatever the c is, that is your y-intercept. And y-intercept is also your ordered pair. Now you got to remember in the y-intercept, the x is missing, so we put 0. And our c value, which is a positive 9. Now that we have that, we got to go find our roots, or our solutions, or our x-intercepts. Okay? So in order to do that, it's factoring. So we're going to use the x method. So we got to factor our equation, which is 3x squared plus 12x plus 9. We're going to check for a GCF, like always. And in this one, the GCF is 3. So everything is going to get divided by 3. So when we divide it by 3, we get x squared plus 4x plus 3. Taking out GCF just makes the equation smaller to work with. Now you can still get the same result if you did it without doing the GCF, but GCF just makes the number smaller. Now that we have them smaller, let's set up our x. At the top is a times c, which is 1 times 3, which is positive 3. The bottom will be the b value, which is positive 4. We set up our size of our x and put our a value at the bottom. And we find our factors of 3 that multiply to give us 3, which is really just 1 times 3. Now we need a positive 4. Signs at the top says it's positive and the bottom is positive. So if that's the case, the top says that the signs are the same. The bottom says that they're both positive. So that. Now that we have that, we set up our two binomials, bottoms up. So that'll be 1x plus 1, and the other one will be 1x plus 3. Now the roots from that is basically you setting them equal to 0 and solving. So if I set that x plus 1 equal to 0 and subtract 1 on both sides, our first root or solution will be negative 1. So one of them is x equals negative 1. Then we do the other one, which is x plus 3. Move that to the other side by doing the opposite. That gives me x is negative 3. So the other solution is negative 3. All right, so now we have our roots or our solutions. Now that we have that, domain. Domain for every parabola is going to be all real numbers. And then the last one is the range. The range in this one is because it's going up, is going to be y is greater than or equal to our minimum value. The minimum value is the y value from our vertex, which is negative 3. All right. So now we have all of our key features. With us having all of our key features, we can go ahead and start graphing. Now when we graph, we start with axis of symmetry first because that is dead center of the parabola. It cuts it in half. So our axis of symmetry is at -2. So we can do a dashed line on -2. Then we graph our vertex. Our vertex is at -2, -3. Then from there, we can graph our y-intercept, which is at 0 and 9. We can graph our roots. Our roots are just dots on the x-axis. So that means we put a dot on -1. That's one of them. And then we put a dot on -3. Now, if you look at that, we have everything that we can graph on the coordinate plane, but we are missing a dot. Now, because we need 5 dots to make a good parabola, we're going to go and look at our y-intercept. Now, if you look at our y-intercept, it is 2 boxes away from our axis of symmetry. And because it is 2 boxes away from our axis of symmetry, if we count 2 boxes on the other side of it, that can give us our 5th dot, which will be here. Now, with that 5th dot, now we can just connect them, and that makes our parabola. So now it's a sketch. It's not perfect. But other than that, that is example 1. Now let's move to example. All right, so now in our example 2. In example 2, it basically wants us to graph the equation. We do need to identify the axis of symmetry, the vertex, the y-intercept, its direction, roots, domain, and range. Okay? Then after we get all of our key features is what it's asking us to find, we'll be able to graph it. So in this one, we start out by listing our A, B, and C. Our A this time is -1. Our B is 4. And our C is -3. Now direction, or which way do it open, is based off the A value. And this one is a -1. So that means this one opens down. Axis of symmetry. So to find axis of symmetry, we do x equals -b over 2a. Now our b value is a +4. Negative is already there, so we just put the 4 beside it. Divided by 2 times our a value, which is -1. That'll give us a -4 at the top, and that's going to be 2 times -1, which is -2. Now 4 divided by 2 is 2, and then a negative divided by negative is a positive, so we get a +2. So that means our axis of symmetry is x equals 2. Now with the axis of symmetry, we use that to plug into the equation to find vertex. So that'll give us a negative times 2 squared plus 4 times 2 minus 3. Now we go to Desmos and we type that in. Just remember that our vertex and what we're about to type into Desmos gives us the y value, okay? And then we use the x value we got from axis of symmetry to make the order pair. So in Desmos, we type negative parentheses 2, raise that to the 2nd power, plus 4 times 2 minus 3. And when we type all that in, it gives us 1. So the y value of our vertex is 1. The x value is 2. So the order pair will be 2, 1. 2, 1. Now the y-intercept is already provided. That is the c value in our standard form equation for our parabola. So, and remember that in the y-intercept, the x is missing, so we put 0, and the c value was -3. Okay. Now that we have y-intercept, let's look at roots. Our roots are our solutions. Okay. Now, in order to get our solutions, we have to factor the quadratic down. Okay. So our equation is -x squared plus 4x minus 3. Now we check GCF. With our GCF for this one, The only number that all three they share is 1, but because there is a negative in front of our x, I want to take this negative out because it makes it easier to factor. And so that means I'm going to take a GCF out of -1. So that means everything is going to be divided by -1. And when I do that, that gives me x squared minus 4x plus 3. Once you get the GCF taken out, we can set up our x. The top of our x is a times c, which 1 times 3 is 3, and it's positive. The bottom of our x is our b value, which is -4. And our sides are going to be divided by our a value, which is 1. Okay. Now with that, we find our factors of 3. That multiplies to give you 3, which is just 1 and 3. All right, so the top of our x is positive. That tells me that, or it should tell you that your signs will be the same, okay? And because the signs are the same, the bottom tells you which number, which is your bigger number, gets the negative. So if 3 is negative and they have to be the same, that means your 1 is also negative. Now we set up our two binomials, which is 1x minus 1, using the bottoms up method. And the other one is going to be 1x minus 3. Now that we have our binomials, we can set them equal to 0 to get our roots. So that's going to be x minus 1 is equal to 0. We're going to do the opposite of that so we can move to 1. So that's going to be x equals 1. And then we do the other one, which is x minus 3 equals 0. We'll do the opposite of that by adding 3 to the other side. That gives us x is equal to 3. So our roots are x equals 1 and x equals 3. Domain is going to be all real numbers. And then our range is going to be y is less than or equal to, which is the maximum value, and our maximum value is based off our vertex y, which is 1, and that is our range. Now that we have everything, we can go ahead and start putting it on our coordinate plane. First thing we're going to do is we're going to draw our axis of symmetry, which is on 2. Then we graph our vertex. Our vertex is at 2, 1. Then we can graph our y-intercept, which is at 0, -3. Then we can graph our two roots, which is on the x-axis, one of them being at 1 on the x-axis and the other one being at 3 on the x-axis. Now, that's only 4 dots. We need to get the 5th dot. And to get your 5th dot, we use our y-intercept. So the y-intercept from my axis of symmetry in this one is going to be 2 boxes away. So that means I go to the opposite side of my axis of symmetry and count 2 boxes away. So that's going to be 1, 2. So that means our axis of symmetry, or our 5th dot, will be here. Now we can connect those dots to make our parabola. All right, so now that we got this example completed, we got it graphed, and we have all of our key features. In this lesson, it was important to know that it's a combination of everything that we should know or have learned about quadratics or parabolas, like direction, axis of symmetry, your vertex, your roots, which is factoring, domain and range, all that is needed in order to graph it, okay? So now that we have completed the lesson, if you have any questions, don't hesitate to ask.